Everyone, thank you so much for coming out today for our co-op talk presentation. So today we're going to be hearing from Irina, who will be sharing her experiences with us as a 1P13 IAI, her materials engineering research positions as well. And I think we're going to learn a lot today about the process of getting a co-op position and working both in education and research. And I think we're all looking forward to hearing about Irina's perspective and about her experience. And so I just wanted to bring your attention to the website we're using for questions. It's called Slido, I think is how to pronounce it. And we will be posting the link in the chat. Jessica has posted it. And so if you have any questions, you can just send them through that website and we'll get to them at the end. And you can ask them anonymously. You don't have to put your name. And okay, so thank you for coming, and I will now hand it off to Irina.
Okay, thank you. I'll just share my screen now. Kind of getting used to Zoom. I never use Zoom, so just give me a second here. Here we go. Does this look all right to everybody?
Yeah, it looks perfect.
Awesome, thank you. Okay, so yeah, good evening, everybody. I'm happy to be here and to be able to share my experience over the past year. So if you don't know already, my name is Irina de Boer. And just a brief introduction. So I'm in my third year of material science. And so you may not recognize me if you're also in third year or second year, because I did take a year of co-op. So that's why I'm a third year now, and technically my fourth. So last year in the fall and winter semesters, I was in IAI for 1P13. And then I did that as a co-op. And then past 2 summers, I've also had research positions at McMaster. So I've been working at McMaster quite a bit, but I have hopefully a few things that I can tell you about gaining those opportunities and applying for those positions and how I did that. And then I guess one other thing is in the winter of this year, I'm hoping and I'm looking forward to possibly doing an exchange to Grenoble, France. It's still a little bit up in the air because of COVID restrictions, but some universities are going through with it. So I'm hoping the same is with McMaster. So just as a bit of an overview for my presentation. So I'll go over first how I found these positions. Then I'll go over a little bit about my year as an IAI for 1P13. And then also what I learned during my research positions during the summers. And then I'll give you a few examples of my work during those research positions and how they relate to material science. And then I'll end up with a few tidbits of advice. So first of all, how did I find these positions? So I have a list of 4 positions here that I obtained in the past 2 years or so. So I started off when an email was sent through the MSc department about this TA position for 1MO3, which is a non-existent course now, but they just needed some volunteers to work part-time throughout the term to help out with running the office hours for this class. So I applied for that position and I received it. And I would say that starting off with that small TA position really helped me when I went to apply to be an instructional assistant intern for 1P13, because I could refer to that experience and I could show them that I have a knowledge about that course, which is one of the courses that now makes up for 1P13, the first year engineering course. And so I actually learned about the IAI position from a classmate. It was a very short notice decision on my part. I think it was about the beginning of August when I heard about the position, and then the application process took about 2 weeks. And then I went from thinking I'd be going into third year into completely changing it around and doing co-op for a year. So sometimes it is a short notice thing or a short notice change that you make and when an opportunity like this comes up. As for research, most of the time when I was looking for research positions, so in the summer of 2020 and 2021, it's mostly involved sending out emails and talking to professors. So for 2020, I sent out quite a few emails. The first email I sent to a professor, He was very enthusiastic, wanted to show me his work, but he did not have the funding, so he couldn't actually hire me for the summer. And that's okay. That happens when you talk to some professors. Some professors may have funding one year and they don't the next, and that happens. But they're also really nice about it because usually they'll know of another professor who does not or who is looking for summer students, and they can pass you on to that professor. And that's what happened for me. So the professor that I talked to first sent me to another professor who actually sent me to another professor in the MSc department. So it was really just getting passed along from professor to professor until there was a research position available. So it was a bit of a process for 2 years ago to find that position. And then the past summer was a little bit easier. I attended a research event that was hosted by, I think it was by the McMaster Research Society or something like that. I forget what it's called. But anyways, I attended that research event just to learn about the research that was done by different groups at the university, and specifically in engineering. And then Dr. Zura was at that event. So I asked him a few questions about his research, and then I sent a follow-up email a few days later asking or inquiring about any possible positions. So like I mentioned, it's really about, finding that first position, and it kind of helps you when you're looking for later positions. So even if it's a small teaching assistant job that you can do part-time, that might help you if you want to find a co-op as an instructional assistant intern, like it did for me. And one research position may help you to lead to the next one. Maybe the professor that you're working with, there's more work to be done on the project that you started, and they may be willing to hire you for the next summer. So I made a bit of a GIF based on that topic. So since you're all in material science and engineering, I think you'll understand this. It's just showing the Gibbs free energy on the y-axis and then the arrangement of atoms on the x-axis. And it's about going from metastable equilibrium to stable equilibrium. So to go from position A to position B, it requires a jump. It requires inputting that extra energy and effort to reach that stable equilibrium. And that's kind of how I felt about looking for co-op positions or research positions, that it was the hardest the first time around, in that I didn't have anything on my resume really to show to anybody that, hey, you should hire me. But once I found that first position, then I had that extra experience that I could showcase to anybody, anybody who is hiring. So I hope you enjoyed the GIF I made. So next I'll talk about my year as an II. So that's just the abbreviation for instructional assistant intern, because it's a bit of a mouthful. They just call us IIs. So I was actually part of quite a large teaching team, the professors, IIs, and TAs. There were about 8 professors for this course, about 11 IIs, and 150 TAs. So quite a lot of people involved in the running of this course. And so if you are looking for a teaching assistant position, I would say definitely look for one in this course if you're starting off, because there are quite a few opportunities there, quite a few TAs that they will hire. But as for being an II, some of the day-to-day activities that I had, so this involved leading virtual design studios, supporting labs, developing courseware, since it was a newly established course, also attending meetings, marking, and office hours. So the typical things that you would do if you are a professor as well, but some of the tasks that professors didn't have time to run, so the IIs took control of. And so I actually gained a few skills from this experience. So here's just a list of a few of them actually. So first of all, I gained a lot of experience using Microsoft Word, Excel, and PowerPoint, which will come in handy no matter where you go in life. So whatever career you're going into. I also gained some presentation and communication skills, I would hope, because I had a lot of practice teaching, especially actually virtual design studios. So needed needed to be able to present, especially when I couldn't see how people were reacting to the content. So it was definitely a very different way of teaching. I also got to relearn some of the first year material, which may sound a little bit boring, but it was helpful in that it helped to establish some of the knowledge that I learned in first year, and it helped me to remember some of it so that I can use it moving forward. And then lastly, making connections with professors and TAs, and especially for those from different engineering streams than material science, which will help moving forward as well. As for why I accepted this position, it was a very last minute decision on my part. I would always toyed with the idea of being a teacher or maybe pursuing being a professor later on in life. And so I thought, this might be a unique opportunity for me to find out if I enjoy teaching and if this is something I would enjoy in the future. And I did decide that I do enjoy it. So it's definitely an option moving forward. And that's some of the things about getting a co-op position is that sometimes you're on the fence about what you would like to do after you leave university. And so co-op helps me to find out, okay, what are certain opportunities that I might like to pursue in the future, and things that I also don't like about certain positions. So it's about finding out what you like and what you don't like from a co-op position. So moving on to research. So in 2020, so that's about 2 years ago, right after the pandemic started, I was supervised by Dr. Gianluigi Botan, very French name. And for this position, I actually was very fortunate in that I received an undergraduate student research award, so an NSERC USRA, we call it. And this is actually a really good thing to apply for if you're going into research for the summer, because it gives you that extra funding for your professors so that they don't have to worry so much about finding the funding themselves for your project. And so the project that I worked on was actually quite different than the project that we had planned back in January when I actually asked about this summer position. And that's because of the pandemic. So originally, I was going to be working at the Canadian Centre for Electron Microscopy, so the CCM, and doing some work on microscopes. And I was super excited about that, but pandemic happened and things changed and I couldn't actually go to McMaster. But it was actually really nice because Dr. Botan, he came up with another project that I could work on during the summer where I could stay at home. So I could do everything virtually or independently as well. And so what I did is I implemented algorithms to deconvolve EELS spectra using Python. So I'll explain a little bit about this in the next 2 slides. But a few things that I gained from this experience. So I gained a lot of practice using Python and just the knowledge of what different toolboxes were available with Python. I also could gain a bit of an appreciation for the applications of programming. So seeing it as a very useful tool when you're in material science. And I also gained an understanding that although I do enjoy programming and I appreciate it as a tool in material science, I would not choose it solely as a career. So there's a definitely reason why I did not go into software or anything programming related. That I enjoy programming, but I only enjoy using it as a tool and not as the main thing I'm working on in a job. So again, learning what I liked and what I didn't like about certain positions. So just to go over briefly what I meant when I started talking about deconvolution of algorithms, it's a bit of a mouthful. So essentially, convolution, which is the opposite of deconvolution. Convolution is when you have 2 functions. So in this case, the animation here is showing a blue box and a red box. And when you move the one function from negative infinity to positive infinity, so from left to right, you have this overlap between these functions. And so the convolution is mapping that overlap, essentially the area under these curves. And so with deconvolution, we're essentially doing the opposite. We're saying, okay, we're given the convoluted function, so f convolved with g in this case, so this black triangle, and we want to find the original function. And this comes in handy when you're given data from an electron microscope. And sometimes that data has instrumentation errors or something wrong with the detectors and anything like that that might skew your data or add something to it, right? And so in this case, you can see in the top right corner here, there's a very wide peak, but in the next two graphs, so the one below graph C, it's quite narrower when we deconvolve it. So we're essentially going and trying to find that original spectrum or the real spectrum that the sample is providing. And then if you further deconvolve this spectrum, you start to see certain features. And so you see what's called the zero loss peak, which is this central peak. And then you start to see two small plasmon peaks here. And I don't really know much about plasmon peaks, but for me, it was just knowing that I could use these algorithms and work with them and kind of use trial and error to see what works the best in order to deconvolve the data that I had into something that was useful. So yes, I guess one thing that I emphasize about this research position, that it was a lot of trial and error. And that's something that comes, I think, pretty much throughout all of research, is that there is trial and error involved. So for the past year, or the past summer actually, I had a research position supervised by Dr. Zurab, like I mentioned at the beginning. And I also applied for a USRA again, and I received one again, which is really quite a blessing. You can get more than one USRA. So I think there's a maximum of 3 awards that you can obtain throughout your undergrad. So if you decide to do research every single summer, you can apply every summer for this funding, just so you know. And so for this, during the past summer, a few things that I did. So first of all, I started off the summer just reading a lot of literature on this topic called dynamic transformation. And then with that knowledge, I started to plan experiments for confocal laser scanning microscopy, which I'll show you in a bit. So I prepared samples for HTCLSM, which is the abbreviation, and then I planned and observed those experiments, and then I repeated the process. So again, there's that repetition, there's that trial and error. You perform an experiment, something doesn't quite go as perfectly, or something else happens that you didn't predict, and you have to go back to the literature, try to determine what's happening on your sample, and if the results are what you're looking for the project. A few other things that I worked on were calibrating equipment and writing standard operating procedures. So just helping out in the lab with a few minor tasks. And then I also got to help out with a few other projects throughout the summer. So sometimes when you're waiting for results, things are a little bit slower than usual. And then I would suggest if you're in that situation during a research position, you can ask your supervisor to if he has any other projects or any other tasks that you can help with, just as a way to keep you busy and as a way to gain experience doing other things. So first of all, what is dynamic transformation? It's a bit of a mouthful again. It's quite a simple topic. So it's the phase transformation from austenite to ferrite that is caused by an applied force. So if you deform a sample, it will have a phase transformation. And this is something that's been observed quite recently, actually. It's a new topic. So studies have been done when the temperature is below what's called the AE3, which is this line right here. I don't know if you can see my mouse, but it's where you have the phases gamma and alpha, and then it turns into gamma, which is the austenite. So the line right separating those two areas. So dynamic transformation, just to reiterate, is when you increase the temperature of your metal or your alloy to a higher temperature. It can be above the AE3, so in the austenite phase. So you know that at that point, based on this phase diagram that we've been given through experiments, we know that our sample should be completely austenite. But what's happened is that some people have observed when they deform those samples at those high temperatures, they actually cause a phase transformation from austenite to ferrite. And it's something that's quite baffling to understand why you'd have this phase transformation when the phase diagram tells us it shouldn't happen. So that's something that a lot of research has been going into, and that's what I worked on during the past summer. But despite all of the research that's gone into it, there's been little or no direct evidence of this phenomenon. So that's why there's a need for in situ experiments, which is basically being able to study this transformation in real time, which provides more direct proof of this phenomenon. So here's just a few images that I collected using high temperature confocal laser scanning microscopy, CLSM, I'll just call it. And so in the left image here, you can see all of these grains, and these are the austenite grains. So right now I'm at a temperature that's above the AE3, so when it should be completely austenite. And then I'm keeping it at this temperature, but then we have a really unique system in that we can apply a deformation at this temperature. And so in this right image here, you can start to see a lot of interesting effects happening. You can see all of these slip lines, you can see some twin boundaries, and you can just see the grains kind of pulling apart. So there's a lot going on in the surface. And that's the challenges that you get when you do in situ experiments, is that you're trying to observe something specific, but there are so many factors that you're controlling that there's also so many opportunities for the experiment to go sideways, or for you to observe something that's not what you're looking for, or that's a result of being in this state at a high temperature and high deformation. So you may be wondering, you did all this work during the summer, did you get any results from it? I would say yes, we got results. Did we get direct proof? I don't know yet. And that's why I'm still really curious about this project, because I'm hoping to continue working on it through the fall if I have time, just so that we can attain that direct evidence of this transformation, because there are definitely lines or plates forming on our samples. That's what we're looking for. We're looking for those ferrite plates to form during this deformation, and they did appear as very straight, broad lines. And so sometimes we've observed a few of those, but it's hard to tell if they're actually ferrite that's forming. So then there's the need to analyze the samples after the experiment in a scanning electron microscope or something else. So it's definitely a lot of complexity to the project. So I talked about quite a bit of technicalities of what I did during research, as well as a few things about how to find positions and I guess about what I learned from those positions. But here are just a few tidbits of advice that I hope will help you in the future. So first of all, I'd say just consider a summer research position. It's a really great way to gain experience. So gain experience in material science specifically, so in this field, to gain experience in the lab, which are skills that you may need in your career. They'll come in handy. And you also get to see those applications of material science, so applications of the theory that you're being taught in your studies. And then lastly, of course, to improve your analytical thinking. I found that during these research positions, it has really helped me when I've returned to full-time studies, and I'm studying, doing courses that I can approach my courses with more of critical thinking and more analytical thinking. And that's really helped me, help my grades, I think. I hope so. A few tips for finding these research positions. So first of all, participate in classes, turn your webcam on or something like that if it's virtual, just so that a professor can put a face to your name, so they'll know you if you send them an email later on asking for a position. Also, don't be shy to ask professors about their work and their research, because this is something they're genuinely very interested in and very excited about, so they want to talk about it. And also, the more interested you are in the research project, the better experience you're going to have. This is, I think the other research students can attest to this one as well, is that You want to work on something that you're interested in. Same for any job, I guess. And the same goes for research projects. So definitely look through the research areas that are available in the material science and engineering department and see if any of those interest you. And then lastly, just ask about applying for funding. So the USRA does go a long way for professors to being able to hire more summer students. I guess besides tips about like research specifically, I could say in general, I'd say don't worry too much about finding the perfect co-op position. Like, of course, you want to find the position that you want, right? I didn't mention, like, I applied for several other positions throughout the past 2 years, didn't get them, and applied for these ones and I got them. So you apply for some, and you have success, you have limited success, right? But I guess in general, what I'm trying to say is if you may not know what you want to do after your university degree, or you may not know so much about the job that you want, these co-ops are the best way to find out what you like and what you don't like about these jobs. So I think I'll end it off there before I make it worse. And I guess just say thanks for listening, and feel free to send me any questions, or send me an email as well if you have any questions later on.
Thank you, Arina. I think this is a really thorough presentation, and I really learned a lot, especially when you say like to learn about what you don't like during those co-op, because like I feel like everyone knows what they like, but they kind of at least I didn't know like what I don't like about some part of this industry until I get in co-op. Yeah, and
Exactly.
yeah, and we do get some questions in the link I posted before, and so the first question is, so when you were a research assistant, did you work directly with Dr. Zurab, or did you work with master and PhD students?
So it really depends on the project, I think. So I worked independently quite a bit, and then I just had usually weekly meetings with Dr. Zurab just to show him progress or to ask him any questions. And then I'd see him sometimes if I was working in the lab. And of course, this was mostly because of COVID restrictions. So if things get back to normal, then research positions may be that you have more time with your supervisor to ask questions and such. So there may be times when you're working directly with your supervisor. There also may be times when you're working with a master's or a PhD student, like you said. And I had that actually in the first research position I had. So I did not work that much with Dr. Breton. I just had a few meetings with him throughout the summer just to update him on my progress. But I was mostly collaborating with one of his PhD students.
Mm-hmm.
So it does change based on the situation.
Okay, and another question asks, how often do you get to use the knowledge you learned in class, and how often do you learn new knowledge during those co-op experiences?
For the past summer, I definitely learned a lot. And there were quite a few times when, I performed an experiment and I saw something happening. And then, or Dr. Zurab mentioned something or explain what's happening. I'm like, whoa, I kind of learned that in class, but I didn't really get to see it. And now I can actually see it during an experiment. So there's definitely been situations like learning about slip lines, learning about how materials deform when I'm deforming them in situ and all of that. And does that answer your question? I think I forgot the last part, maybe.
Yeah, which is how often do you learn new knowledge? But I guess that, like, it's all the time because you're constantly like accepting new knowledge from like this project, right?
Yeah, so you're doing a lot of reading throughout the process as well. So constantly learning about your project or the more detailed things about it. And then as well as not just learning, theories and stuff like that, you're learning skills. And so you learn a lot of lab skills when you do research.
Mm-hmm. Okay. And our next questions asks, so I've heard a lot about the Grenoble. Oh, actually, there are two questions asking about the Grenoble exchange. and
Okay.
asking what was it about and how long is it and how did you get involved with it? Like basically, like, how did you start?
Yeah, for sure. So I think usually in second year, at some point, there's a presentation about this exchange opportunity. It's in a unique opportunity within our department because it's specifically between McMaster and Grenoble, the university in Grenoble. Um, so yeah, there will be probably a presentation that you have throughout the year. I learned about it from that presentation in second year, and it was told to me that if you are in the material science program, so just the straight material science, you're typically going to do this exchange during your third year. So the winter semester of your third year, which is what I'm doing right now. And I think it changes if you're in iBiomed or a management and society program. But yeah, feel free to ask any specific questions about the Grenoble exchange. I'm still kind of learning about it because it's been up in the air for the past like half a year. And yeah, really hoping it goes forward.
Yeah, and just to add on to what you said, I'm actually going there as well. And we just interviewed a past student that went to Grenoble, I think the year before last year, and we're gonna like update the notes when we interview her on the website. And if you are interested, like feel free to go on our website. And yeah, so hopefully that helps. And our last question asks, as a material students, how much is programming generally involved in the program and in jobs and in co-op positions?
I think it varies. I think in second year, I had a few courses that, used programming for just one or two assignments. So just a little bit to keep you, remembering some of the Python language. And then over my co-op as an IAI, I was involved in helping out with projects for the students. So I was running design studios where we gave them essentially time to work on their projects. And these projects were, they were different projects. There's 4 of them throughout the year, and 2 of them were, they had a computing aspect to them. So I had to be familiar with Python when I was helping students out with their projects. For the summer position I had in 2020, I think that was, like I said, it was all programming. So that was, I think it was about 30% of the time I was actually doing programming, and then 70% of the time I was doing the research to know, okay, what algorithms or how am I going to implement this into a program. And then I would say in the third year, this year so far, I have been using programming more. So it may depend on your courses that you choose. So like when you get into later years, you have technical electives, and some of those technical electives will use programming. So right now there's a course called machine learning. I think it's, machine learning and material science and chemical engineering. That's the one I'm taking right now. And programming is a heavy aspect of it. But most of my other courses, I think it's just a minor element. So it really does vary. I think if you can choose your courses to avoid it, but I would suggest, try to stay familiar with your programming because it will come in handy no matter what in your future, I think.
Yeah, definitely. I think for me personally, in second year, I didn't do any coding at all except for my lab doing the math course. But then now it's all coming back during my third year. Like we're learning numerical methods now, so we're using MATLAB. And then for statistical methods, I think like another course about stats. So we're using Python for that one. And yeah, so I gotta pick up some old knowledge from the past too. Yeah. And I'm just seeing we have another questions here. So it asks, how did your work experience affect the kind of specializations or field you're interested in?
That's a good question. Honestly, I still don't really know what I want to do leaving university. Like I've toyed with a few ideas of, okay, what if I stay in research and then I really enjoy what I'm working on now, which is focused on its metallurgy, right? Just the broad field of metallurgy and just a project that's specifically dynamic transformation. So I do really enjoy what I've learned over the past summer, and I think maybe I could continue doing something like that in a master's or a PhD, but I still don't know. I don't know if I'd be able to stick it out for that long, or did I just go into industry. Um, yeah, co-op has really helped me to find out what I like and what I don't like, but I'm still on the fence about a lot of things. But I think that's okay. I think there's more people that are like that than just me. So don't be worried if you are as well.
Yeah, I think that's fair because co-op is all about like reality of what you think, right? And yeah. All right, I think that's all our questions now. We can wrap it up now. And thank you, Arena, for coming and talking to us and sharing all these helpful information.